Hello everyone, welcome to Chemistry Shots. Today let's discuss what are homotopic, enantiotopic and diastereotopic groups. So first let's see what is homotopic group. They are chemically entirely identical groups. Let's discuss more about this with this example. So here we can see two same groups are attached to this carbon, that is OMe, say two same OMe groups are attached to this carbon, and we have two protons here. Now we have to see what is the relationship between these two protons. Anyway, one proton we can see that is towards us and the other one is away from us. To see the relationship between these protons, what we have to do? We have to replace one hydrogen with some other atom or group. Let's see, for example, we are replacing this hydrogen with chlorine and we'll get this structure, and we are replacing this hydrogen, we'll get the other structure. Now see what is the difference or what is this relationship between these two structures. We can see that since same groups are here, from this molecule we can just reach this molecule by a 180-degree rotation, which means that these two are conformers of a same molecule. Okay, so these are same molecule. That means replacing either of one hydrogen from this structure, we will get same molecule itself, which means that the relationship between these two hydrogen is nothing but they are homotopic, or we can say that they are chemically entirely identical protons. Since they are chemically entirely identical, we'll get the same NMR spectrum for that, or we can say that they will be exhibiting same chemical shift in the NMR spectrum. So that's about homotopic. Also, the point that to be noted in the case of homotopic is that they cannot be distinguished by any chemical reagents or enzymes or the one that is NMR. They already discussed. Okay, so that's about homotopic groups. Now let's see what is enantiotopic groups. Enantiotopic group are magnetically equivalent. Let's discuss it more with this example. In this case, we have two different groups attached to carbon. Okay, so that here one group is OMe and the other group is pH. The one hydrogen is towards us and the other hydrogen is away from us. The same way what we have done in the case of homotopic, we just have to replace the hydrogen with some other group or atom. Let's see, we have replaced this hydrogen with the chlorine, we'll get this one, and we'll replace this hydrogen with the chlorine, we'll get this structure. Now see what is the relationship between these two structures. First of all, we can see that on replacing one hydrogen from this structure, we will get a chiral center because the four atoms attached to this are different, which means that this is a chiral carbon. Okay, so now we can see what is the relationship between these two. If we are giving R as notation to these two, we can see that one will be R and the other will be S, which means that these two are related. By the way, these are enantiomers. Okay, so these are enantiomers, so that the relationship between these two protons will be that they will be enantiotopic. They will be enantiotopic protons because on replacing either of the hydrogen from this, we got an enantiomers. Okay, so what is the case of enantiomers in NMR spectrum? NMR spectrum cannot distinguish enantiomers, so that they will show the same chemical shift in NMR. Then how can we distinguish enantiotopic groups? We can use enzymes or some asymmetric reagents. Only these things can distinguish enantiotopic protons, but NMR cannot. Why? Because NMR machines cannot distinguish right and left, so that they cannot distinguish the enantiotopic protons or enantiotopic groups in general. Now moving on to diastereotopic groups, they will be chemically entirely different groups. Diastereotopic will be chemically entirely different groups. Now consider this example. Generally diastereotopic groups we can identify very easily because in the structure they will be having an already existing stereogenic center or chiral center. We will be already having a chiral center. Generally, the groups attached to a chiral center or the groups which are neighboring to a chiral center is generally diastereotopic in nature. For example, let's discuss with this example. Here we have a chiral center already, which is this carbon, which is a chiral center because four different groups are attached to it. And Now consider the nature of the relationship between these two protons. Actually, in this structure, we can see that these two structures will be mutually diastereotopic. These will also be diastereotopic to each other. For a clarification, let's discuss about these two protons. We are replacing this proton with chlorine and the other proton with chlorine. So we'll get these two structures. So suppose this chiral center, we are on giving RS notation, we are getting R, and this one is also getting R. So just by interchanging the hydrogen and chlorine, we'll get S and R. So one is R and the other one is SR. So what is the relationship between these two? They are nothing but diastereotopic. So on replacing the hydrogen and Cl, either of the hydrogen with Cl in this structure, we are getting diastereomers. So the relationship between these two structures is nothing but they are diastereomers, or they are chemically different. So the two protons are diastereotopic protons. Also, they can appear at different chemical shift in the NMR spectrum. Even though there are some exceptions, because in the case of toluene and all, even though there are diastereotopic protons, we will get the same chemical shift in NMR. Since still we can say that they will show a different, in general we can say that they will show different chemical shift because they are chemically different molecules. Diastereomers are chemically different molecules. They can be distinguished with some chemical reagents, etc. Also by NMR we can distinguish them. Now to conclude, what we can say, if on replacing the two protons or two groups we are getting identical molecule, then it is said to be homotopic group. And if we are getting enantiomers, then we can say that they are enantiotopic. Or if we are getting diastereomers, we can say that they are diastereotopic to each other. The point to be noted is that diastereotopic usually arises when the molecule have an already existing stereogenic center. Okay, so that's about diastereotopic, enantiotopic and homotopic. Thanks for watching and subscribe for more videos.